Good morning, everyone. Today we are talking more linear equations, specifically how to find the X and Y intercept of a line. Now, first we got to answer the question, what is an X and Y intercept? Well, if you sort of take the root of that word intercept, it sounds kind of like the word intersection, and we're going to be able to use those two sort of interchangeably because the X and Y intercepts are the points of our line that intersect with the X and Y axes. And so we can say that the X-intercept is the point where the line intersects the X axis, and the Y-intercept is the point where the line intersects the Y axis. And so if we take a look at our graph over here, this point right here is going to be our X-intercept, and I'll just abbreviate that X int. And this point over here, because that's where it intersects with the y-axis, is going to be the y-intercept. And so now that we have a sense of what these are and where they show up on the graph, how can we actually find this point? Now, the key to do this is to look at our graph here and notice something special about these 2 points in particular. If we look first at the X-intercept, this is going to lie along the x-axis, right? It has to by definition. This is where we intersect the x-axis. So if it lies along the x-axis, it can't be up here, it can't be down here. It always has to have this point where y is equal to 0, right? We're not up at all, we're not down at all, we're always neutral in the vertical direction. So this will always occur when y is equal to 0. And likewise, our y-intercept over here, it's not to the left of the y-axis, it's not to the right of the y-axis, it's always going to fall neutral in the horizontal direction. And so this will always occur when x is equal to 0. So we can find the x-intercept when y is equal to 0, and we can find the y-intercept when x is equal to 0. And if we keep these two things in mind, then for any line y is equal to mx plus b, or in any of the other various forms, we're always going to be able to use that to get to the x and y intercepts. And so let's see if we can take this line as an example and find the x and y intercepts of y is equal to 2/3 times x minus 2, which is the line we have pictured to the left here. Let's start with the x-intercept. We know that this occurs when y is equal to 0. And so if this happens when y is equal to 0, we can take our equation and substitute 0 in for y. And now we have 0 is equal to 2/3 x minus 2. Well, this is going to allow us to solve for x now. And if we do that, we add 2 to both sides. We'll have 2 on the left equal to 2/3 x on the right. When we multiply by our reciprocal, multiply both sides by 3/2, we will get the 2 and the 2 to cancel on the left, leaving us with 3. The 3/2 and 2/3 to cancel on the right, leaving us with x. And we have x is equal to 3. And what this tells us is that the x-intercept, the place where we intersect with the x-axis, occurs when x is equal to 3, and of course, when y is equal to 0. So we can say, therefore, the x-intercept is the point 3, 0. And we see that here on the graph, right? This is our point 1, 2, 3, 0. And so we can always find the x-intercept by plugging in y is equal to 0, because it will always occur when y is equal to 0. Now, to find the y-intercept, this is going to be very similar. Just in the case of the y-intercept, this occurs when x is equal to 0. And so if we plug in 0 for x, then our equation becomes y is equal to 2/3 times 0 minus 2. 2/3 times 0 is just 0, and 0 minus 2 is -2. And so now we know that the y-intercept is going to occur when y is equal to -2. Now, we also know it occurs when x is equal to 0, so we can say, therefore, the y-intercept is 0, -2. And we see that reflected on our graph as well, right? We're 0 units left and right, and we're 2 units down, so this is the point 0, -2. Now, another common variation of this question may be asked when, instead of being in slope-intercept form, which is y is equal to mx plus b, our line is given in standard form, which is ax plus by equal to c, like we have in this case here, 4x minus 3y equal to 8. But while this looks slightly different, actually solving it is going to be still the same. We can work with our x-intercept first, remembering that this occurs when y is equal to 0. And so we can set y is equal to 0 in our equation, which gives us 4x minus 3 times 0 equal to 8. 3 times 0 is of course 0, and so we have 4x equal to 8. When we divide both sides by 4, this gives us x is equal to 2. And so our x-intercept is going to be the point 2, 0. Similarly, for the y-intercept, we know that this occurs when x is equal to 0. And so if we substitute 0 in for x in our equation, we'll have 4 times 0 minus 3 times y equal to 8. 4 times 0 becomes 0, and so we're left with -3y equal to 8. When we divide both sides by -3, this will give us y is equal to -8/3. And so we can then say our y-intercept is the point 0, -8/3. And the one last thing that I'll note here, as we've seen in both of these cases before, and as you will always see, is that the x-intercept is always going to be in the form of x, 0, right? Because it's going to have some value x, and y will always be equal to 0. And the y-intercept likewise will be in the form of 0, y, where we'll have some y value where it intersects with the y-axis, and the x value always equal to 0. I hope you found this video helpful. Thank you for submitting your questions, and thank you for watching. Please feel free, as always, to submit more questions in the comments down below, and I hope you have a great rest of your day.